Today's daily code problem of the day is separate black and white balls, number 2938. For this problem, there are n balls on a table, and each ball has a color black or white. We're given a zero-index binary string S of length n, where 1 and 0 represent black and white balls respectively. So 1 is black, 0 is white. In each step, we can choose two adjacent balls and swap them. So if we're going to swap balls, they have to be right next to each other. We want to return the minimum number of steps to group all the black balls to the right and all the white balls to the left. So if we look at our example here, we have 101. We want to get all of our 1s to the right, all of our 0s to the left, and that means we just need one swap. We can swap this 1 and this 0 to get 0, 11, and that is all we have to do for this example. In example 2, we could see with the number 100, we need to make two swaps. We'll first swap 1 and 0, and then we'll swap these two, which is going to be 1 and 0 again, and ultimately we will end up with 0, 0, 1. So we will need two steps. We can also look at some test cases here, like 0, 0, 1, 1, 0, 0, 0, 0, 1, 0. We can begin to see a pattern. So if there's 1, 0 to the right of a 1, it requires one swap. Now let's continue adding these zeros. So we have 1, 0, 2, 0, 3, 0, 4, 0, 5, 0 to the right of this 1. So that means this 1 is going to need 5 swaps to get to its final place. Same thing for the next one. There's 5 zeros, and we reach our next one, which means it only needs 5 swaps, which makes sense. So this one will go to the first 0. This one will go 1, 2, 3, 4, 5, end up where the last one is. And then this one will go 1, 2, 3, 4, 5 into the next 0 next to the other one. And this will solve this solution. So, how do we implement an algorithm that counts how many zeros are to the right of a 1 and add it to our total amount of swaps needed? Well, first, we're going to take notice that we need to return a long variable. So we're going to initiate a variable long, which is going to be our total moves. And we can set that to 0. We're also going to keep track of the amount of zeros to the right of our 1s. So we're going to have an int zeros. They'll also start at 0. Now we're going to iterate backwards through our string like I did on this test case and count the zeros from right to left. And each time we come across a 1 character, we're going to add that to our total moves. So we're going to have a for loop, and our integer I is going to be equal to our string s. So our string s dot length, and then we're going to go ahead and subtract 1 so we don't go out of bounds. And then as long as I is greater than or equal to 0, I will subtract 1 from its value. So we're going to traverse the string backwards. If whatever character we're currently on, so if s.char at I is equal to a 1, we can go ahead and add whatever our 0 value is to our total moves. So total moves will plus equal our zeros. Otherwise, this means that we're looking at a 0 character. And when we're looking at a 0 character, we simply want to increment zeros by 1. This algorithm will count how many zeros are to the right of each one, and when we come across a 1, it'll add the total number of swaps required to move that 1 into a proper place and add it to our total moves. So we can simply return our total moves, and that's it. So if we run this, it passes our test cases, and if we submit it, it passes all solutions. It has a time complexity of O of n and a memory complexity of O of 1. So that's it. Thank you, and follow for more daily LeetCode solutions.